to 4.3, number 8. Anytime we see a cosecant or a secant or a cotangent, we're going to use the reciprocal function, right? So let's go ahead and change this to a sine, which is the reciprocal of cosecant. So sine of 1/3 x minus pi. And that's going to equal the opposite, or the reciprocal ratio, 1 over square root of 2, right? Now, if you want, I've kind of been doing this in the last couple of problems, but you might want to actually stop and let some other variable, like u, equal 1/3 x minus pi. I guess normally I would use something like theta. U works, theta works, whatever you want with it. So this means that we would find u by doing the inverse sign of basically square root of 2 over 2, correct? Because that's the same thing as 1 over square root of 2. It's just the way we're used to seeing it. Okay, so that is a 45-degree reference angle. So that would be pi fourths in quadrant 1. Or quadrant 2 would also be positive. So that would be 3 pi fourths in quadrant 2. And then, of course, plus 2 pi k to give infinitely many answers, because we need to do that just in case it affects the answers between 0 and 2 pi. If it was just 0 to 2 pi and this was just an x and there wasn't any of this fancy stuff, then the answers would be pi fourths and 3 pi fourths and we would be done. Okay, let's go ahead and plug this stuff back in for you. So we have 1/3 x minus pi equals pi fourths plus 2 pi k. And then we're going to have 1/3 x minus pi equals 3 pi fourths plus 2 pi k. Right, let's go ahead and solve each equation separately. So 1/3 x equals, and we're going to add the pi to both sides, so that would be like adding 4 pi fourths to our pi fourths. So that actually takes that quadrant 1 and moves it to quadrant 2. Likewise, this one over here, I mean, I could work on each one separately. I'm just kind of working with them. Same idea with both problems at the same time. So this one would be adding pi to both sides, so adding 4 pi fourths. So that would be 7 pi fourths. Okay, now we're going to get rid of 3. So we're going to multiply everything by 3. So that gives us x, and that gives us 15 pi fourths plus 6 pi k. Weird, huh? Everything multiplies by 3. So wherever 1 is going to. And then same thing here. Over 1 times everything. So x equals 21 pi fourths plus 6 pi k. Alright, now we're looking for answers that are just 0 to 2 pi. Ugh, this is definitely over 2 pi. What if we let, so if we let k equal 0, we're going to have 15 pi fourths, but that is not between 0 and 2 pi. So let's let k equal -1 and see what happens. If k equals -1, we would be taking 15 pi fourths, and we would be subtracting 6 pi. So I would be like subtracting 24 pi fourths, right? Because that's the same as 6 pi. K equals 1, -1 rather, just making it subtract. So 15 subtract 24 would be -9. Doing that right? Pi fourths. And that is not between 0 and 2 pi. Right? That's not a correct answer because that's smaller than 0. Okay, well what about this one? This one would be kind of the same idea. We'd have 21 pi fourths and we would subtract 24 pi fourths, which would give us -3 pi fourths. That one is also smaller than 0. I'm beginning to think we don't actually have any answers between 0 and 2 pi, because if I go backwards and add that 6k back in, I would just get what I would have had if k equals 0. And adding 0 to this is definitely not going to make it fit between 0 and 2 pi. There are no solutions. In 0 to 2 pi. There are other solutions that are lower than 0 or bigger than 2 pi, but there are none that are from 0 to 2 pi. Ooh, this one has a squared. So this would be the same thing as saying the cosine squared of x equals 1/4. Right? So this would be the same as saying the cosine of x is equal to plus or minus 1/2. I put the square root in there to get rid of the square, which means I have to include both positive and negative possibilities. So the inverse cosine of plus or minus 1/2 means it could be anywhere in all 4 of the quadrants, right? So all quadrants, positive or negative, and it's going to be a pi over 3 reference angle, right? So all of the answers from 0 to 2 pi would be x equals pi thirds, 2 pi thirds in the second quadrant, 4 pi thirds in the third quadrant, and 5 pi thirds in the fourth quadrant. If we go higher than that one, then we'll go past 2 pi. It's a very common mistake if you get a problem like this to forget that plus or minus part and to think, oh, it's just positive 1/2, so it's just pi thirds and 5 pi thirds, quadrant 4. So it's very easy to forget the others if you forget to do that plus or minus when you take a square root. So just a note here, square root both sides means we have to do plus or minus on our answer.